No.
Now, when you guys did work with arc length and areas of sectors last year, they probably set it up a little bit differently for you. You probably worked with ratios and proportions, I think, with that.
No.
No, whatever. No. So,
Nobody knows.
yeah. What happens here, the way that we're going to do this is we're going to change, and like I said, basically from now on, we're going to be dealing primarily within radians. So if I'm going to give you an angle degree, like you need to find arc length or area of a sector, we have to immediately make sure we talk about it in terms of radians. Remember, arc length is the distance on a circle. It's part of the circumference, and the sector is part of the area of a circle. So there's two very, very easy formulas to work with. The arc length, they use the letter S, not exactly sure, is going to be your radius times theta. And theta is always your radian measure. So if they give you something in degrees, you have to switch it to radians. Yes, ma'am? Okay. So if I give you a real simple example, say that you have a circle, a radius of 4, and a central angle of 40 degrees, and I want to find the arc length, you're going to find that this is nothing more than a direct substitution problem. I start with my arc length is going to equal 4 times 40 times pi over 180. And again, I'm converting from degrees to radians. I multiply it by pi, divide by 180, and this is where you guys need to make sure you're focusing. Watch how I simplify a fraction with my brain. Is there a 0 in the top and the bottom? So I can divide them both by? Okay. What's half of 18? What's half of 4?
2.
What's 4 times 2? There's your arc length. Again, it's simplifying the fraction by working through easy division. Yeah?
Yeah, where did you get that equation?
Arc length is radius times theta. Theta is the degrees in radians. Yes, sir?
What was the for area?
I'm going to go back to that. I just want to do this one first and bring it up so you guys can see it.
Radius times
Theta. Theta is your degree measure in radians. So you have to convert your degrees to
40 pi
radians.
over 180.
Yep. If I wanted to do the same idea where I'm working with the arc length here, or not arc length, excuse me, the area of the sector. That's 1/2, oops, the radius squared times theta. Again, we're working with theta as your degree measure in radians. Your radius is going to be whatever. If I want to do a different one here, let's say we have 8 for a radius and 80 for our degree measure. Direct substitution, 1/2 of 8 squared times 80 pi over 180. What's 80 squared? 8 squared.
64.
What's half of 64? All right, so right now I have 32 times, well, drop that through. 18 and 8, what can you simplify them by? 2 comes up 4, and this is a 9, so it's 32 times 4 over 9 times pi. Does a 3 go into 32? Well, do you guys know how to check that? What's 3 plus 2? Can you divide that by?
Wait, 5. I'm sorry, I multiplied that. That was dumb.
Anyway, let's try this again. What's 3 plus 2?
5.
Can you divide that by 3?
No.
No, so I cannot simplify this any further. So, what's 32 times 2?
4. 64.
Doubling. So you get 128 pi over 9. And there's your area. No, what's 1 plus 2 plus 8? Can you divide that by 3? You're done.
Your simplifying is just so
Drastic.
nice.
Thank you.
Yeah.
This is an unfortunate skill that I'm finding that most of you guys have never learned.
Never.
We do a lot of it here. You're gonna try, you'll pick up on it real quick, okay?
At the-
Again, what you're working on here is just two very simple formulas. You're gonna be given something in degrees. You might be given it already in radians. Substitute in and go for it. Radius is 9, and your angle is 60 degrees. Please find your arc length, and please find the area of the sector. Take a second and do it. Check to see how we did here. Arc length again, take the radius times your central angle in radians. Again, this should not be very scary to simplify.
Yeah, that one's easy.
0, 3,
Over.
3, you get 3 pi,
Yes.
okay? On the other one, we were talking about the area. 1/2 of, what was it, 9 squared times 60 pi over 180. Half of 60 is 30 times 81 over 180. (27 pi over 2). Again, do you need to take half of 81? Commutative property of multiplication tells me I can multiply them in any order that I want. So I took half of 60 to make my life easier. Okay. There's lots of little tricks that you should be able to pick up on. Lots of little tricks. I know you guys love this very much. It's just simplifying. I should get some of those problems for you guys and help you work on fractions. Fractions are awesome. Okay. The second part of today, I don't think we need to do any more of these. Like I said, they're very straightforward. I don't foresee you guys having too much of an issue with it. The other part I wanted to really talk about today was how in the world are we going to graph things when they are in terms of radians, and then how do we find their positive and negative coterminal angles? But that's going to help us base. We're going to base that off of your friend and mine, the unit circle again. So, what we're going to do today is we're going to walk through how we set up a unit circle, and throughout the day today we've come up with a lot of very nice shortcuts to remembering all the different spots. Now, yesterday we started with 0, 90, 180, and 270, 360. Today we're not talking about degree measures, so I'm going to start at 0, and if I go one revolution, what do I end up at? I don't know what a 360 is. 2 pi. Which means this is, this is, and? Okay. That's how we set that up to start with yesterday. Now, the other easy way to continue with that is to take half of half. What's half of a half? So here is, now, a nice trick that you can do is going from 0 to a quarter to a half. You're going up a quarter each time. So isn't this 3/4?
Yeah, really good.
4/4?
5/4,
5/4? 6/4?
7/4, 8/4.
And you've gone,
Pi.
all right, so you've gone all the way around like that. After we did that, we worked with that 30-degree angle. And we found that 30 degrees, yes sir?
Would you explain to us the last one? I'm sorry, I got arc length, arc length 3 pi, and area.
27 pi over 2, I believe. Give me a second, I'll come back to it for you, okay? We said that 30 degrees was, what?
1/3.
A third of 90? So what's 1/3 of a half? 1/6. So that meant that every time I went up 30 degrees, I was going up 1/6. Now here's a shortcut for those of you that don't like to do fractions in your head. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, and 11/6. We went up by 1/6 throughout the entire revolution. Go back and simplify the fraction. When you go back to simplify the fractions, you can get 1/3, so this is, oops, call that pi over 3. 2 pi over 3. 4 pi over 3. 5 pi over 3. So I think it was all of them, right? Yeah. Now some of the cool things you might notice, which you probably don't. Not saying that's bad. Pi, 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 pi. The first quadrant, everything's pi for the numerator. 2, 3, 5. Aren't they all one less than the denominator? You remember what we also saw yesterday? 6, 4, 3, 3, 4, 6, 6, 4, 3, 3, 4, 6. Remember that from yesterday? 7 is 1 more than 6, 5 is 1 more than 4, 4 is 1 more than 3.
They're like odds, like double.
This was 1 less than double. 3 times 2 is 6, subtract 1, you get 5. 4 times 2 is 8, subtract 1, you get 7. 6 times 2 is 12, subtract 1, you get 11. And a lot of little mnemonic things you can do to get there. If you remember, first quadrant always has pi in the numerator. You remember 6, 4, 3, 3, 4, 6, 6, 4, 3, 3, 4, 6. You're going to be all right. Okay? You're going to be all right. Probably not, because you won't have time. You won't have time to draw it and fill it all in. What you will probably, once we get into the actual ordered pairs of the sine, cosine, sine stuff, once you know the first quadrant, everything else is mirrored off of it. Once we start talking about how the reference angle works, all you really are going to wind up working with is that, and everything else is just mirrored off of it. And it's just knowing where things are positive, where things are negative. It's really not going to be that bad. Okay? I'm trying to just get you guys as much seeing it as possible. So when I want to talk about where I'm going to graph something that's within radians, I want to graph 2 pi over 9. I want to figure out what quadrant it is in. The easiest thing to do is to just figure out, well, is 2/9 bigger or smaller than 1/2? Smaller. So if I'm going to graph this, it's smaller than 1/2, which means it's in the first quadrant. There's 2 pi over 9. Yeah. That's pretty much it. If you're thinking about it, you're going to have 4 different cases. Between 0 and 1/2, between 1/2 and a whole, between a whole and 1 1/2, and between 1 1/2 and 2. You're going to have to look at the fractional amounts and decipher whether or not which one it's going to wind up in as you're moving yourself around the circle. Okay. We are also going to use this stuff not only to plot a rough idea of what quadrant it's going to be in, but I'm also going to ask to find the positive and negative coterminals. So I'm going to use 2/9 as our example. 2 pi over 9 is right there. It's in the first quadrant. The next positive value that has that as a terminal side would be 2 pi away from it. Do you agree? So instead of adding 360 to 2 pi over 9, I'm going to add 2 pi because it means the same thing. But now I'm working with the fraction. What fraction am I going to write 2 pi as? 18 pi over 9. Everybody hear that? There's my positive coterminal. When I'm going to go for the negative coterminal, instead of adding 2 pi, I'm going to subtract. What's 2 minus 18? Very good. And there's your negative coterminal. What's going to be a little bit weird when you're dealing with radians going with positive and negative coterminal angles is that the biggest suggestion that I can give you is to automatically write 2 pi in terms of the fractional with the common denominator. And I think most of you guys should be able to do that off the top of your head. Okay? All right, let's try it over. Pi over 12. I want to graph it, figure out what quadrant it is in, and then get the positive and the negative coterminal. There's a couple of nice shortcuts that you can do here. To figure out what quadrant you're going to be in, you're just going to ask yourself, how many times does 12 go into 19? Once. It went in one time with how many left over? 7 over 12. Now, that means it went in there one time, so that means there's 1 pi here, so it's going from here to here. Everybody okay with that? Now, 7 over 12. Is 7 over 12 more than half or less than half? It's more, so what quadrant are we going to end in? 4. Very good. There's my angle.
Wow.
Does that make sense?
Yeah.
Remember, each time, each quadrant is half the circle. Each quadrant is going to be half of 2 pi's, 2 pi over 2. So again, since this original angle was 19 pi over 12, it was within 1 revolution. In order to find the positive coterminal, what am I going to add to it? Yeah, good. What is that, 43?
Yeah.
And then I'm going to subtract it. Okay. Yes, sir.
So you're always adding 2 pi to it?
Yep.
Because that's just 360 degrees, is
Yep.
that why?
Yep. Now, you got to be careful. What happens if you're more than 1 revolution in terms of
It's
pi?
more than 2 pi.
Yeah, you could bring it back around. And I've got another one like that here in a second.
Alright.
It's not that bad. It's the same idea if it was 780 degrees. You back it out till you're within 1 revolution and then go from there. All right? Let me show you that example.
You just keep subtracting.
Yeah. Same idea. It's the same basic principle. Pi over 4. I'm going to graph it. I'm going to find the positive and negative coterminals. First thing I'm going to do here is I'm going to show you 2 ways to think about this. 4 goes into 13 how many times?
3 times.
3 times, and how many are left over? All right, so it's 3 1/4. So if I'm looking at this graphically, 1 pi, 2 pi, 3 pi, quarter pi. Everybody okay with that? It will be in the 3rd quadrant, but yet I went around more than 1 time. So to start with, to get the positive coterminal, what do I need to subtract out? 2 pi, right? So there's 2 ways you can go about this. If you recognize that it's going to be larger than 2 pi right away, you subtract 2 pi, you're going to get 1 1/4 pi. Is that within 1 revolution?
Yeah.
So that's 5 pi over 4. Or subtract 2 pi. What do you get? 5 pi over 4.
So you didn't even do that.
No, you can go either way. I think sometimes people see this better when they're graphing it instead of trying to figure out, all right, 4 goes around 3 times, am I going all the way around 3 times, or am I just going 1 pi, 2 pi, 3 pi? That's why I like to write it out as a mixed number, just to show how many pi's you're crossing.
So when you do that, like when we graph it, do you want us to go all the way around and then show us just what?
Yeah, just that. Plus, it helps you count.
All right.
You
So
know.
you want us to do the spiral thing?
Won't hurt.
All right.
So there's your positive. What do you subtract from that to get the negative? And there's your negative. Okay? All I did was I subtracted 360 again. In other words, I subtracted 2 pi. Not so bad? Preguntas? Tarea para su clase de matemáticas?
I don't speak Spanish. I'm learning
So I know she's going to go to Stone.
except on the phone set.
All right. Where's my? Two students. I tried. De Espanol, escape Plano. Oh, let's see what page it's. I think it's the same exact page that 781, but I'm gonna give you guys the ones that are more with radiant stuff.
Wait, it's the same unit? The same
Yeah, it's the same stuff. Yeah, it's the same section. I wanted to split it into the 2 parts. Because come Monday, we're going to basically be dealing always with the. So this is on page 781.
Oh, is our homework?
Yeah,
Think we'll finish in class maybe?
probably.
No.
Can you put it on the board? Put it on my book.
Isn't it just, it's pretty much the same problem. Looks like. It's the part that we didn't do. Also grab PLS.
Okay. What I put in there was the first 4 of them are the same. Not 46. It should be 43. Excuse me.
I mean,
Lo siento.
was that mean blessing?
Yes. Again, what I did here is first 4 problems are nothing more than graphing in radians. Find a positive, find a negative coterminal angle. After that, the next 6 are arc length, area of sector, and the last 6 are very simple word problems, dealing with things in radians. For example, how many radians do you go in a school day for the hour hand?
I found it.
Something like that, okay? All right, go ahead and get started on that. Yeah. There wasn't much going on with these things today, so it shouldn't be that bad. Yes, sir. Oh, I'll show you. Yeah, I'll show you that in a second. Let me just stop this.